Okay, so I have the data file and I have the worksheet tab open, and I have this original least squares analysis of it with my p-values and that sort of thing. So now what I want to do is start removing columns, paying attention to my adjusted R squared as I go. Now again, right now it's kind of nonsense at 1.66, but we'll see it also can become nonsense a little later. Um, but the way I want to go about this is, I started with everything and now I want to start trying to throw things out. And probably what I'll try to do is go by the largest p-value. So I'm going to look down here to find the largest number. Now, what you can do is to kind of help you make sure you found the largest one. Um, Although, as long as you're going for really big ones, it probably doesn't matter too much. But you could always do something like I could say equals maximum and highlight this row. Um, Now I'm going to include the intercept here, but I'm never going to throw out the intercept because it really just doesn't matter to me. Um, and throwing it out may make things bad. Okay, so I do that and I see, oh, the maximum is 0.9903. So now, see, I can go through here and look, and there's 0.9903. It is column 2, and that's why these numbers help greatly. So I can go over here to column 2, and actually I can, what's nice is, so that's population density. It looks like in the total scheme of things with all these interactions and the original variables, um, this isn't adding anything. Okay, so we can figure we're independent. Our incidence rate. Oh, I never fixed that, did I? So that should be an IR. Um, uh, so it looks like incidence rate is probably uh, independent of this. And we can look at plots and all those things as well. But right now at this point, I'm just kind of going strictly with the numbers. So I'm going to click here at the top of the probability density, population density, and I'm just going to go in here and say delete that column. And so it does now. As we look here, you see what happens is we now get this column where it says NA, and but everything else is fine. Now what we need to do though is update here. So I'm going to highlight there. We got rid of 2, so I'm going to take everything to the right of 2. I'm going to cut it, and in here I'm going to paste it back. And I get a warning, and I do that. So now you see I can still tell what my variables are, but it's kind of important to do that so that you know what column you're looking at. And now the maximum it has that NA in there, and so all I really have to do is come back a column. So whatever comes before G, I guess that's F, and I hit that, and now I see my maximum is 9.716. Oh, that's right there, column 28, and that is the interaction between no diploma and meeting all the criteria for the work-ready county. So that's the biggest. It's really huge, no question about it. I don't want that in there, and so now I'll delete that column. Okay, and when I do, now I'll just highlight all of those down to 0, and I'll cut that and paste it on the 28. This is my method for renumbering, but you can renumber any way you want. You just want to make sure you've got things matching the right column numbers. And so again, we've I'll go back here one more. And so now the highest is 0.9645, and I'll kind of look around here. Whoops. Where is that? 9.6. If you all see it, yell to me. Oh, there it is. Okay, and so that's column 5. And actually, kind of surprising, column 5 is, the flu vaccine. Whether the county had high or low rates of getting the flu vaccine, doesn't really seem to have much prediction quality for the incidence rate. And so, okay, we'll get rid of that one. Okay, and so what I got rid of 5, so I'll come back here and again get rid of those and then paste them over the 5, and so things are starting to take shape. Notice the R squared, adjusted R squared, it's going up, which is a good thing, but this 2.95 is silly. It should be between 0 and 1, but actually as you continue this, you should get a negative number at some point. But once you start in the negatives, you should also see those increase. So when R squared is increasing, that is a good thing. And so you want to just kind of keep going this way. And let's see, so I'm going to go down here to a B. And you see I'm still at a p-value of 0.9. I mean, that's huge, right? 90% chance of getting these data basically, or in other words, the 90% chance that the slope is indeed 0. And so, yeah, I think we don't want whatever's 0.90, and we can look here to try to find it. See an 899. It's in there somewhere. There it is. Okay, and that is column 9, which is what? That is the interaction of the proportion voting for Bashir, or the percentage, with the median income. And so you continue this way. Now what I'm going to do is put this on pause and get rid of a whole bunch of these, and kind of look at what you should be hoping to find, something pretty close to it anyway. So let me pause it. Okay, so I've taken out a few more columns. I'm down to k equals 22, and notice my adjusted R squared became negative. So at 23, it exactly matched the degrees of freedom, and I had a bunch of a bunch of hashtag things there, or pound signs. But then when I got it down to the 22, I got a adjusted R squared that's negative. Okay, which is also silly. But what we'll see is as I reduce columns, this adjusted R squared gets bigger. Okay, and it starts heading towards 0, and then it gets bigger than 0. And so I'll pause it again. Now, what you should find is you can get down to k equal 13. And the adjusted r squared should rise to 0.21. And your overall r squared is 0.52. You should be able to get somewhere in there. And now, as you look at the p-values here, notice, that's bigger than 0.05. That's bigger than 0.05. And there might be one or two other ones. Now, that, of course, is the intercept, so we don't worry about that. That's bigger than 0.05. And so it looks like there are three of these that are bigger than 0.05. So you might think, oh, you want to get rid of those. I certainly thought I wanted to get rid of those. But what you should find is if you do get rid of any one of those columns, actually your adjusted r squared drops. And so for the model, what I would suggest is you keep those things in there. Okay, so I would keep that column and that column and this column because up until then, when I was at 14, I had a smaller adjusted r squared. I think it was maybe 0.20 something, or it might have even been 0.212. And then I went to 13, and it didn't drop. Actually, I think it went up just the tiniest bit. And so I would like the number of columns to be as small as possible, and it looks to me at this point for this model that is as small as I could do with the columns I started with. Okay, so we get there, but now I'm going to pause it just for a second, and we're going to look at something I noticed in the columns, and try to work with that. Okay, so let me pause it here again. Okay, so what I noticed was these last three columns here, these interactions. It was the UP, that was the uninsured proportion, the flu vaccine proportion, and then the work ready meeting all categories. But notice, okay, the interaction here with UPFV and then UPMC, but then FVMC. So you see they all three are paired with each other. Okay, which made me wonder, well, actually, instead of a pairwise interaction, maybe it's a much more complicated interaction where it's all three. And so, at this point, my data file isn't set up to do this, just like this. So, what I need to do is kind of recalculate a column, and that's probably the easiest thing to do. I guess I could insert a column, and everything over here will go haywire for a minute. But I need the original values, the original normalized values of the UP and the FV and the MC anyway, so I'll probably go back to the data interactions file tab to do this. But I need to make a new column, and that new column I'm going to make is UP, FV, and MC. And I'm just going to put it here in 23 because I'm going to get rid of that. Now, I've already done this, so I know the answer um, uh, is a good thing. And so when when I was doing it, actually, I did insert a column so that these three columns weren't changed, and I inserted a column and calculated it, and just looked here to see, how things did. And it did fine, and then I deleted the columns I didn't need. Well, here I'm going to write over this column, and then delete these two columns that I won't need. Okay, so notice, they're all well, two of the three are significant, right? This coefficient here for the what was UPFV was not significant. It wasn't bad, it was down at 0.07, but it was definitely not below 0.05. But these two are down at 0.01. And again, the only reason I thought of doing this is because you had UPFV, UPMC, and FVMC. So you had all possible pairs of those three. So I thought, well, maybe the interaction could be all three. So what I'm going to do is hit equals and go to my data interactions. And I want UPFVMC. So I'm going to, I've got my equals. I'll click that. So that showed up, and then I'm going to say times, and then I'm going to click that, and then times, and click that, and so there I've done it. I hit enter, and now I need to remember to copy that all the way down. And of course things look sort of bad for a moment because I have data that's really built from these other two that were already significant and all that. But now I'm going to delete these two, and hopefully this works. I think it does. Oh yes, look at that. That's beautiful. So now this is column 23, and don't know what those are. All right, but I don't know. And notice that significance for this column, even better yet, the others were at 0.01. This is down at 0.005. And notice the adjusted R value went up. Now, it didn't go up greatly, but it did go up. And I was able to reduce the number of columns here. Now, I still need to keep track of variables because these are the interaction, but I've reduced the number of columns and and gone to this, and then notice I see, oh, this column not significant, that column not significant, and that one's definitely not significant at 0.35. So now the question becomes, oh, can I throw out some more? Okay, can I throw out some more of these columns? And if so, what can I get to? And so right now we've got our columns down to 11, our adjusted R squared at 0.22, and again I'm going to pause it. Okay, so now I changed that to a 29 just so I was consistent with keeping all the column numbers as their own thing, and since this was a new column, I called it column 29. But notice, so we had been at 11 columns. I was able to remove 3 more columns and get the adjusted R squared to 0.26. Now the overall R squared is just 0.41, or about 41 or 42% of the variation is explained by this model. But the adjusted R squared, which is the better measure in the multiple regression, that's as big as I've been able to make it, okay, at 0.26. And as we look at things, there are a couple things here. That's just a little over 0.05. That one's a little over 0.05. But I think, oh, and that one's just a little bit over 0.05. But I believe if I delete any one of those, my adjusted R squared drops, and uh, and so the model isn't quite as good, and the p-values for everything tend to go up, and so this looks like a pretty good answer. Now with real life software, what's nice is you can get it, you can just give it your original data and essentially ask it to check, all interactions, all different combinations of interactions. Because again, we went through this in a particular order. Well, what would be better would be if we just tried each and every possibility. Just delete one column every time, see how that does. Delete two columns, but every pairing of two columns, and check all those and keep track of them, and kind of come up with our best model and best answer that way. But yeah, we can't, without the help of software, we aren't going to be able to do that. So this is a pretty reasonable method. And again, I've gotten it down to 8 columns, of which it looks like 1, 2, 3, 4, 5 are significant. Now again, this is the intercept, so I don't care that that's really big. And so, and there's a little below 0.01, a little below 0.01, again below 0.01. So, these three are less than 0.01. This one's down close to 0.01. That one's only 0.02. So really some pretty good estimates here as far as what variables are good predictors. And it looks like you want these other variables in there, or these other columns really, because most of these are interactions. So you want these interactions in there to help explain what's going on. Okay, but then once you find them, right? I can go to this column, this column, this column, that one, and say, hey, it looks like these columns do a nice job of predicting how what the incidence rate might be. Again, we only have one given day. It might be better to get an average or something like that, but nonetheless, we have this, and and we can also say, well, these other columns, I want them in the model, but the model ends up kind of saying that they're not strongly associated. Okay, they are part of the model. It looks like they're important to the model, but again, at 0.05, 0.06, 0.07, they're above our alpha value, and so we probably don't want them. Okay, so there I'm pretty happy. I've gotten this. I started with 28 columns, got it down to 8 columns, and so that's much better. And by looking at those columns and what they are, I can talk about the interactions and the straight up variables and so forth that seem to be important in predicting the incidence rate, at least in our counties in Kentucky on a given day in April. Well, really for a given week. Okay, and I think that does it for this video.